For a recap here, there's 4 training sessions. Today is session 2. Rick Gerber is going to give us an overview of the geology of our area and some of the processes and work that we've been doing over the last number of years.
Anyway, welcome everyone. As Steve said, my name is Rick Gerber. I'm a hydrogeologist with the Oak Ridges Moraine Groundwater Program. And I guess last week Steve kind of went through an overall summary, I think, of the various components of our program and how you can get at a lot of different information sets and data on our website. Today, I'd kind of like to dive into a little bit of interpretation of that information, some of the components and aspects and things we think about, just to give you an idea of maybe the depth that it takes to put together I call it a conceptual model, which is basically our understanding of how the flow system functions within our study area. So we've called it kind of geologic interpretation for this seminar. So I'll obviously focus on geology. My problem is I like to bring in groundwater information because I think it informs geology. So I'll give you a bit of a flavor of that too. So basically what I want to do is maybe go half of the time to the website, half the time of slides, because I want to provide some background as to how we kind of go about things and give you an idea of our mindset. But so basically I'll go through kind of like the regional geology. According to me, obviously all geology seems to have a bit of bias in it, and maybe you'll be getting a bit of mine, but try and overlook that. I'll talk a bit about how we develop our conceptual model and focus on the geology part. In that, I guess I've been practicing for a number of years. Things aren't cut and dried. There's always disagreement and discussion going on when you talk about geology, and I'll touch on that. I'm not going to go too deep. Explain how we construct our three-dimensional geologic surfaces, and then I'll bring in a little bit of the hydrogeologic flavor. For instance, groundwater levels, do they differ on either side of, say, a till aquitard, that kind of stuff, how we bring that in. And then we'll go to the website, and remember, it's always evolving. And another thing I want to, at the bottom here, I said, let's continue expand ongoing dialogue. I have an ongoing dialogue with a lot of people about a lot of the things we're going to talk about today. And in my opinion, the more eyes looking at things and criticizing things and testing interpretations, the better. So I guess this is an invitation for if you feel inclined, please let us know what you think, especially if you disagree with our interpretations. So to set the stage, our study area is this purple zone here. It basically incorporates 3 source water protection areas: the Trent, the Lower Georgian Bay, Lake Simcoe, and the Credit, Toronto, and Cloca. So basically what we're looking at is, in the white are uplands, so the Niagara Escarpment, the Canadian Shield, and then the Oak Ridges Moraine also forms another height of land running east-west through the center of that area. The geology beneath our study area, and this is from the Ontario Geologic Survey, and this is a printout from our web page. But the OGS also has another way of looking at their information. Obviously, you can download, but they have OGS Earth, which is a Google Earth application. So that's another source or place where you could look at information. So basically, within our study area, we're looking at Precambrian rocks. We've got Ordovician carbonates moving east to west into Ordovician shales. And then we climb the escarpment as we move west into Silurian rocks, so sandstones, dolomites, shales, etc. And when you look at that area, this is bedrock topography at the top. And again, it's mimicking the ground surface topography, where the whites, the snow-capped peaks, I guess, are the Niagara Escarpment here, the Canadian Shield up here, and then a broad lowland, I think most recently referred to as the Laurentian Trough or the Laurentian Bedrock Valley, running down from Georgian Bay and into Lake Ontario. And I guess over the last, let's call it 135,000 years, we've preserved or built up a succession of Quaternary sediments that can be over 250 meters thick. And both of these maps I've taken from George Gow's work at the OGS. I guess that this broad valley here, some people may think it's glacially carved, some people may think it's an ancient fluvial system, and I'm borrowing this figure from Nick Isles here, an ancient river system that when the ice sheets left, we formed the Great Lakes. We're not going to really get into whether it's one or the other right now, but then again, that's just part of the theme of there isn't complete agreement on the geology for our study area. So most of our study area involves this infill over that bedrock trough or the Laurentian Bedrock Valley. So if I draw a cross-section line from, let's say, the east side of Simcoe down to Lake Ontario, what we've got is a buildup. There's that 250 meter thick package of Quaternary sediments over bedrock here in white. And for the most part, what we're looking at is from about, say, 135,000 years ago to about 20,000 years ago, we were basically looking at a large lake filling in this trough. Okay, so think, I guess, rivers flowing off of the uplands into a large lake. That lake is varying its water level. And then there may be a glacial component in here, a proglacial, beneath the glacier, subglacial component to that, but we're looking at extensive lacustrine deposits in here. And again, think for grain size, think proximal distal, close to a sediment source, coarser grain, sands and gravels. Distal from a sediment source, which could be a river, think silts and clays. And then about 20,000 years ago, the continental ice sheet was at its maximum down into the States, and this light green layer is Newmarket Till, basically over consolidated. I think people to the west of the escarpment may know it as Catfish Creek Till. We're saying that those units are coeval. And up until the ground surface, for the most part, we're looking at extensive areas of till at surface. So to the north of the moraine, we're largely looking at Newmarket Till. To the south of the moraine, and the moraine being in here, this orange is Oak Ridge's moraine deposits. We have mainly Halton Till. I'll get into the extent of that a little bit later, but for the most part, we're looking at flanking till deposits on that of the moraine. So when we look at these lacustrine deposits in the lower sediments, and that's a term coined by the GSC, Dave Sharp, Hayes, and Russell, basically includes like the Thorncliffe Formation, Sunnybrook Drift, Scarborough Formation. So we're in a large lake, and that seems to be constrained. And on this next slide, the colored area are where we to date have interpreted any kind of thickness of that lower sediment. So basically in gray, I'm showing the OGS bedrock topography. So basically this lower sediment, we tend to pinch it out as we climb up the Canadian Shield and as we climb up the Niagara Escarpment. And we're basically just infilling with that large lake with lower sediment. Then over the last 20,000 years, when we look at our ground surface expression, we have a ridge of the Oak Ridge's moraine, and that is basically considered to be, if you notice, there's 4 pods or wedges moving from east to west. The idea is that we're in a subaqueous environment where we're looking at fan deposition between glacial ice lobes. So it's constrained on either side of glacial ice lobes. So the maximum extent 20,000 years ago would have been glaciers down into the States. then we back off a bit and we're talking about a couple lobes that meet or close to meet along the moraine ridge. So we're looking at, in the east, the Rice Lake wedge, the Pontypool wedge, the Uxbridge wedge, and the Albion wedge. And then we've taken that, I guess, that quaternary layering, and from meltwater, I guess, beneath the ice or proglacial, again, there's a lot of discussion going on as to how. I mean, the fact of the matter is we see a lot of valleys, okay, throughout our study area, predominantly north of the Oak Ridges Moraine in here. So there's a lot of discussion in the literature about how these valleys formed. Were they catastrophic meltwater floods? Were they just eskers beneath the ice? I guess the point here is that we have interrupted our stratigraphic succession with valleys, and the key being that some of these valleys, and particularly the Holland Marsh, we think that extends or eroded all the way down to bedrock and then infilled with a fining upward sequence, because where there's gravels at the base and fining upwards through sands and silts. So we have our quaternary layering that's been interrupted by these erosive and depositional events, basically from glacial meltwater. So when we build our conceptual model and our geologic interpretation, it's not necessarily all of our ideas. We borrow heavily from the Ontario Geologic Survey, and they have a lot of boreholes that are cored, and detailed geological analysis have been done on those. We have boreholes from the Geologic Survey of Canada. We have boreholes we've put in that we've cored and logged. We have large major infrastructure projects, sewers, water main projects that provide a wealth of information. Geotechnical studies associated with highways from the Ministry of Transportation, landfill investigations, TTC geotechnical investigations. So I'm not mentioning everything here or showing everything here. I guess the point is that we basically collect all of our, let's call it higher quality information, and then kind of emanate out from those points, incorporating things like information from Ministry of Environment, water well records, etc. So another pattern you may notice, and I'm not showing all high quality data here, but is that for the west half of the moraine, we have a lot more higher quality information than we do over the eastern part of the moraine. And as far as nomenclature of our geologic units, we're borrowing from researchers, we're borrowing from the OGS, we're borrowing from the Geologic Survey of Canada, Dave Sharp, and we're using the nomenclature that they have developed over time. And again, I mentioned that there is a lot of discussion going on regarding the geology, and this has been going on for decades, and it may continue for decades. But the point of the matter is, in general, and I'm saying almost here, in general, there is generally agreement about the units that exist. Okay, their extent may be in dispute, but for the most part, we can use the nomenclature and feel comfortable with it. I think one of the differences is that when you look in the literature, the discussion is, how did these units form? What is the depositional environment? And I guess as a hydrogeologist, you would say, you know, I really want to know the depositional environment because I want to know how extensive a unit might be. I want to know what facies changes may occur within that unit, because ultimately I have to translate that into hydraulic conductivity. So I'm not saying that the depositional environment isn't important here, but I think one of the things that maybe can soften that blow is that the scale of these structures. So we're talking about beneath a glacier, we're talking about huge lakes. So we're looking at very large structures that, for the most part, I think takes away some of that apprehension about what is the depositional environment. And then back to our cross section running from along Lake Simcoe to Lake Ontario. So we, like I said, we've taken the geology from researchers, GSC, OGS, but we do have some little differences. Like I think our conceptual model has room for different interpretations of depositional environment and units. But for the most part, what we've done is we've looked at, if you look at drumlins and lineaments, etc., north of the moraine and at the eastern half of the moraine, for the most part, we're looking at approximate southwest direction. So we're saying we're going to make that Newmarket till. Okay, once you get west of Port Hope, some of the glacial lineaments that are on surface generally have a north to northwest trend, and that's usually attributed to the Halton till. So what we've done is to the north and to the east, we've taken the Newmarket till and we've split it though, because what we think is that we've got a lower part, which is basically lower Newmarket till, very over consolidated, almost like a concrete sidewalk. We also see in some locations silts and sands between till units, so an upper Newmarket till and an inter Newmarket sediments and a lower Newmarket till, and that's different definitely from the GSC's interpretation where they've lumped all this together. Just want you to be aware that we've split it, and that may have a hydrogeologic, we do that hydrogeologically, let's just leave it at that. To the south of the moraine, we have Halton Till Complex, and we've extended it further than, say, the GSC's mapping or Dave Sharp's mapping. For the most part, we've taken it right down to the Lake Iroquois shoreline, and we've incorporated this MIS, ORAC, Mackinac interstadial sediments, Oak Ridge's aquifer complex sediments, because we think down on the till plain, the south slope, we see sands and gravel units in local areas. The thickest I've seen them is 9 meters thick, but we think that's a mappable unit. But then again, I just want to point out that that differs from the interpretation of Dave Sharp. And then another thing that it may be different, I noticed that a recent paper by Sukan and Nick Giles suggested that the Halton Till also occurred below the Lake Iroquois shoreline. In our conceptual model right now, we've brought the lower Newmarket Till out to outcrop below the Lake Iroquois shoreline, or if you move further west into Toronto, you may be looking at Sunnybrook Drift, that surface. So there are slight differences, but like I said, a conceptual model is always being tested and refined. So future refinements may change that slightly. So when we render our 3D geologic surfaces, we're incorporating a number of different pieces of information. We're picking formations at boreholes, so these would be X, Y, Z points. We're looking at where, say, bedrock outcrops, making points from that. We have pushdown points, which are basically where we have very deep wells or boreholes that don't intersect rock, but they go below areas where we've interpreted, if you just do a straight Krieg or 3D interpretation, these points suggest that we need to push down the bedrock surface. We have lines of contact that we can incorporate into our rendering, including interpretations from seismic lines or geophysics, and we generally use these to help form channels and bedrock valleys. And then we have some post-processing practices or routines that we run. We don't want crossovers. We don't want anything coming up above the ground surface. So there's a number of different pieces of information and steps that get incorporated. And for instance, we're going to see some surfaces that are on the website. So periodically we release 3D geologic surfaces. We constantly have working surfaces. So basically what we're doing is we're testing these all the time. So like I said, it's discussion with the experts at the OGS, the GSC, researchers, Paul Caro, Nick Giles. Over the years, there's a lot of people that have a lot of ideas. We're always testing our surfaces against those. We're testing them against hydrogeologic information. We're testing them within numerical flow models. So it's not just a straight Krieg and there they are. There's a lot of thought and testing that goes into it. So, for example, a lot of our interpretation is done on cross section, where we show various pieces of information here for a well. We're showing, as the MOE has a map 1, 2, 3, we're showing different materials, clay, sand, gravel. We can draw lines of contact, and here we're saying this line is what we think is the contact line between Oak Ridge's deposits above, channel sill below. We can constrain where we think we have channels on plan view, okay, so that these lines of interpretation only come into the Krieging when they're within an area that's defined on plan view. So there's a number of different things. Another thing we want to look at is screens. I want to see where all the people put their wells, because chances are that might be a sand unit, and in this case, we're interpreting it as Thorncliffe. So there's a lot of different pieces of information that we're visualizing. Another thing that we do, and I mentioned, well, I didn't mention it, but I should have, is that when we correct surfaces for crossovers, etc., we have to set up a hierarchy of what's the most important. So, for instance, the DEM, we know that because you can see it, it's measurable. Our next important surface is the Bedrock Valley or the Bedrock Topography, because we're, like I said before, constraining our lower sediments within a bedrock valley. We have differential coverage of information. So these yellow dots are boreholes where I can pick bedrock at an elevation less than 135 meters above sea level. You can see I have a whole load of locations that give me that information along the lakeshore. But as I move north and the Quaternary sediment thickens, I'm using less points to try and render that bedrock surface. So we can have picks and outcrops, push down points, and then if we need to form the surface any further, we use polylines or lines of contact. And just to give you a flavor, forget about this pink up in here, a flavor of the difference between, say, the OGS 2006 surface, George Gow, and our 2015 simplified surface. For the most part, in this colored area, you can see where we've overprinted a bit of a fluvial system. So there's a bit of art going into this. And again, we're always testing this, but you can see that we have used some polylines or lines of contact to try and form a fluvial system on top of that. So there are slight differences between the two interpretations. And then another thing we're always trying to do is bring in historical knowledge. So I guess people's experience over time. In this case, what we're looking at is in the 1930s, a treated water tunnel was built along the Ontario lakeshore within shale to convey water across the city. This is the tunnel here, and what they found was that periodically they would hit bedrock valleys. Okay, so they don't want to be in Quaternary sediment, so they had to go down beneath these valleys with their tunnel. And in general, that's informing us that these channels, so running along the Keating Channel and out Coxwell near the old racetrack, we're looking at less than 400 meters wide and maybe 30 meters deep in these areas. So we're trying to collect information from any source that we possibly can, any and all sources that we possibly can. And briefly, hydrogeologic indicators. There have been some analyses along the Yonge Street Aquifer. All these blue lines are municipal wells that have informed us that perhaps we need to refine our conceptual model. There was a major construction project in the mid-2000s where sewer work was being conducted, and these orange triangles are former municipal wells from the 70s and 60s. That the sewer came along here and they had a hard time controlling groundwater where the old Markham wells were. And what they had to do to control groundwater to allow construction, I think, is providing us some information that we need to adapt. And again, this could tie into some of this channel and valley talk that's going on now in the research, particularly through Dave Sharp, Riley Mulligan, people at the OGS. There's a lot of great discussion going on. So I'll just give you a bit of a flavor on these two things. So in the Young Street Aquifer, when we do pump tests, and let's call it short-term responses here to pumping, we generally see boundary conditions, which is suggesting that after a certain amount of time, we're hitting different hydraulic conductivity material, and in this case, lower hydraulic conductivity material as we move out from the pumping center. Over time, and I'm looking at 1950s through to the present here, we've got groundwater levels that have responded to different pumping scenarios. And then I've marked, we're looking at major changes in pumping. So in 08, there was a major change in Aurora, and we seem to see a response running up a line, moving through north through Newmarket, Holland Landing, and Queensville, which suggests to us that we may have some kind of a channel aquifer going on in that area. So we had to look at this because for the most part in our conceptual model, when we're looking at channels or valleys, you can kind of see them on the DEM, on the ground surface DEM. This channel along the Young Street Aquifer wasn't completely visible, particularly underneath the moraine down in the south here. So we thought perhaps we have two different ages or multiple ages of channelization going on, finding upward sequences from gravel to sand to silt and clay rhythmites. So we've recently introduced the refinement into our conceptual model where we need to deal with Thorncliffe age channels. The younger ones we're calling Oak Ridges Moraine age channels. So again, the hydraulics here are telling us that we may need to adapt, or we do need to adapt. And again, here's that other example where Stouffville is here. Sewer work had a hard time in this area near former municipal pumping wells. And the drawdown cone, and I'm pulling these contours of a drawdown from Conestoga Rovers, now GHD work, and that drawdown seemed to emanate northeastwards up to Stouffville. Okay, so perhaps we have another channelization going on within the Thorncliffe here because I'm underneath the lower Newmarket Till, and perhaps that structure extends down to former municipal wells. We're looking at very good wells, 1,000 gallons a minute down along Steeles Avenue and Pharmacy, Don Mills, that area where we had former pumping wells, municipal pumping wells in that area. So that's in progress, working on this channel. So to summarize then, we think we have a couple of ages of channels, the key being whether we see lower Newmarket Till or not. Okay, so our refinement of our conceptual model is trying to incorporate, let's call it a facies change, I guess, within the lower sediments to include coarse-grained sands and gravels in the lower sediments. And then another way we test our geology is we ask questions like, where do we see cold water fisheries? Can I explain that with my 3D geologic interpretation? Where do I see flowing wells? A lot of it is along the south slope of the moraine, confinement by the Halton Till, where the Oak Ridges moraine sediments are coming down between two tills, lower Newmarket and Halton. And we're testing this by trying to make mapping of if you were looking for groundwater trouble, where would you go? So a lot of construction projects recently have run into groundwater issues where they need to control groundwater heavily for the short term or perhaps forever. And we're calling these areas of concern. And we think that we can tie them to 3 or 4 different hydrogeologic settings. Areas where we're confining a shallow aquifer, areas along slopes, and again, we're looking at Iroquois shoreline here, where the Thorncliffe may come into play. Do I see coarse-grained channels in the Thorncliffe? So that would be Markham-Stouffville, that would be the Yonge Street Aquifer. And when I get south of the Moraine, particularly, say, the west end of Toronto and into Peel, are my bedrock valleys shallow enough and are they infilled with gravel that may form a problem for construction from a groundwater standpoint? So we're working on mapping with engineers, project engineers from various partners on trying to map, here's areas we know we have problems, and here's areas that may be similar. So we're calling that areas of concern mapping. So I'm going to move to the website now. That was a quick overview, I think. How am I doing for time? Not too bad. And again, what I would like, we're always testing and refining our conceptualization of the flow system. And I guess the idea would be the more eyes looking at this, the better. The more eyes critical of it, the better. So if you want to be involved in that, we are all ears, especially visualizations that you folks have in your day-to-day work. So with that, I am going to go to our website. Can you see that okay, everybody? Steve? Okay.
Yeah, all good, Rick, all good.
Thank you. So when you come to our website, I'm going to go to the sign-in part, and I've already opened it up. It goes through disclaimers, etc. Steve did a lot of this opening up various components last weekend, so I won't dwell on it. And what you see is there's a lot of places where you can interact with information through maps. You can interact with data through searches by well name or location. You can do a report library search. And I'm going to go to the maps for now, maybe do a little bit of a report library search. But when you go to our maps, there's a long list of maps by theme. So basically, we started with a bunch of different themes: geology, water table, water budget. We've since gone to bring them all together into a consolidated map. So you can look at a consolidated map, or you can look at the different themes. Oh, I've already got this open. Let me go to it. Okay, so basically, I've gone into the consolidated map, and in it, if I click up in here, you can see the various themes. Okay, so I'm clicked on the geology theme right here. And when I do that, a number of different pieces of information come up. And just remember that this is always a work in progress. We're including more information as time permits. But basically, right now I'm showing the DEM. We're showing a couple of geological features. So the edge of the Canadian Shield, the Niagara Escarpment, the edge of the Niagara Escarpment. I can turn on the Iroquois shoreline, which is generally about 135 meters above sea level. It's different out in the east end. These tunnel channel thaw wigs are where we have Oak Ridge's age channels, okay, because our conceptual model started with a general Oak Ridge's moraine coeval time period of channels. Our interpreted bedrock valleys, there's the thaw wegs. Hummocky topography from the MNR, all kinds of different data sets that we can play around with. Another thing that I also like to bring onto here, in this layer catalog, I can bring in all kinds of information from a lot of other themes. And a couple of useful ones that I find, I like to see flowing wells, I like to see higher quality boreholes, so PQ cord boreholes. Boreholes where we have a supplementary log, so maybe we have a consultant's log or a researcher's log that we can compare to the MOE water well record. So I'm going to turn those on so that they can be at my disposal. And I'll wait for them to load here. I think people are following around. This is taking a while. Anyway, let me turn off the PQ cord boreholes and just show flowing wells. So for example, I may want to say, where are my tunnel channel thaw wegs? And do I get flowing wells focused on them? So these are the valleys that occur in the DEM north of the moraine. So these thaw wegs, I'll turn that on and off so you can see. And it looks like, yeah, there might be a relationship between flowing wells and that structure. Again, in the background is the DEM here. That's what the color is. So I can click on that and it'll tell me the elevation. But you can see congregation of flowing wells along the south slope of the Oak Ridges moraine. That's a big construction concern, as depending on how, well, there you don't have to dig very deep and you can run into that problems there. Do I see flowing wells in our bedrock valleys? So if I turn the bedrock valleys on and off, yeah, we've got some flowing wells down along here. I know for sure we have a huge one in High Park, some down up along the Don Valley. So you can play around with different data sets with this. Let me put on PQ cord holes. You can make bookmarks of extents. So I'm going to show our entire study area. And I'm going to turn the PQ boreholes on and off. And there's that theme again of, for higher quality information that I have at my disposal, there's a lot more on the west half of the moraine than there is on the east half. So that one component then is geological features. We can look at physiographic regions, and this is basically Chapman and Putnam that was digitized by the OGS. Okay, so we can look at, I'll just wait a sec here. Maybe I'll turn off the PQ boreholes. We can look at the regions. So I can click on a region, and because the DEM is in the background, the ground elevation comes up first, but I can flip over, and that area is the Peterborough Drumlin Field. I can also look at the just straight physiography, which is the materials. If I click on that, I just get the elevation of the ground surface. I have to right click, find data on map, and from the physiography, I'm basically looking at a sand plane. So all these polygons in here are mapped as sand plane physiographically. Let's turn that off. The bedrock geology, which we looked at before, that's from the Ontario Geologic Survey. And they've released digital mapping. Let's get rid of that. So you can click on a polygon, and because I have the DEM again in the background, it gives me the ground surface, but that's the Lindsay Formation. So it goes by formation here. If I want to view additional details, I can get more detail on what the materials are, in this case limestone. So you can do various querying on the layers. Let me turn that off. Another thing we've got in here is bedrock topography. Actually, I'm going to turn the DEM off. Bedrock topography, and notice I have MNDM, so the OGS has an interpretation of the bedrock topography, and then we have an interpretation of the bedrock topography. And as I showed before, they're quite close, except that we, and this is ours on top, have imprinted this fluvial kind of system with tributary valleys into ours. Again, subject to refinement, but if I turn on the OGS, turn ours off, you can see where we've kind of imprinted that fluvial system. But anyway, they're both at your disposal. You can click on that, and this is the OGS bedrock topography, and at that point, their elevation, interpreted elevation of the bedrock surface is 108 meters above sea level. Another map at your disposal is Quaternary sediment thickness. I was taught I shouldn't call it overburden, so I won't, but our website does. And you can see the reds would be thicker Quaternary sediment. The blue would be thinner. You can see the thickness of the Oak Ridges moraine coming into play here. You can see the thickness of the bedrock valleys coming up to Laurentian Valley coming into play here. Again, let me put on my flowing wells. And again, maybe relate them to Quaternary sediment thickness. So if I go down into the city, we do have some areas where interpreted bedrock valleys do contain some flowing wells. It's just running a little bit slow. Perhaps people are following along. And this is an area that we've mapped. A bedrock channel coming down through High Park. What else do we have here? We have, I can turn that off, turn the overburden thickness off, turn the flowing wells off. How am I doing for time? I guess I have about, maybe I'll spend another 5 or 10 minutes with your indulgence. Overburden thickness, we have land use, soil-risk land use. We have superficial geology. And again, we have I got to look at the OGS geology. I've got to zoom in a little bit. The various superficial geologic units that have been mapped by the Ontario Geologic Survey over time. And we'll wait till it loads.
Hey, Rick.
Yeah.
It's Annie. Turning off the transportation layer at the top there might help a little bit.
Okay. Oh, that's just the road network, major road network. Thank you, Annie. And on this layer, I can right-click, find data on map. And remember, this is the OGS. And I'm Unit 5B, which is a stone poor carbonate-derived silty to sandy till. So you can get information on the various polygons from that. I can do the same with the Geologic Survey of Canada related to their work related to the Oak Ridges moraine. Simplified, I guess, the OGS various map sheets. And we have theirs available too. And again, this has taken a bit of time, perhaps because a lot of people are trying to follow along. That's not showing up. Okay, there it is. And we can query this map too. Superficial Geology, GSC, Unit 3F. glacial deposits till sandy silt to sand. So I'll get rid of that. And other map sets or info we have here, we have elevation by formation. So this basically means that we have interpreted tops of. So in this case, we're showing an interpreted top of Halton Till. We have interpretations of the top of Oak Ridge's moraine sediments. You can click on it and it gives you an elevation. A couple things that we'd like to add to this soon are being able to plot picks or geologic picks in boreholes where you can see, it's particularly going to come into play for some of the deeper units. You can see the density of points that were used to render that surface. Another thing we probably would like to bring in here soon would be the isopachs, or the thicknesses of these various units that you can then query and look at on the map. I think I'll, in the next couple minutes then, so that's the geology theme that you can get on that composite map. Another page I'd like to take you to is cross sections, where you can draw cross sections through our interpreted stratigraphy. Let me bump out a little bit. Whoa, bump out a little bit. So, for instance, as we talked about earlier, we have that 3D rendering of geologic units. If I'm working in a certain area, I can say I'd like to create a virtual borehole, and I'm going to be drilling here. So what did some people interpret as the geology at that location? And then a virtual borehole, I guess, comes up with various layers that you can turn on and off. So the top of the Scarborough, we're interpreting that at 175 meters above sea level. You can do that to check. You can draw a cross section. So let me draw one that in the general area of where we had those cross sections that we saw in the slides. Again, I'll be in the general area. It doesn't have to be 2 points on a line. It can be a line going anywhere. And then you double click to end, and hopefully a cross section comes up quickly. In this case, you can turn things off. I'll turn the water table off. I'll turn that upper bedrock off. You can turn wells off. In the future, we're thinking that we'd like you could be able to click on a well, and the well logs, the various logs that we have, would be able to pop up. We're not there yet. But again, another thing I'd like to point out to you, and that was based on those differences of interpretation between the various research groups. But for the most part, in these surfaces we have here, so the Newmarket Till, which highlights when I hover over it, to the north of the moraine, these are simplified surfaces. So we haven't split out the upper Newmarket, the inter-Newmarket sediments, and the lower Newmarket in this version of posted surfaces. Okay, just so you know that. When we haven't specifically posted Oak Ridge age channels, they're generally incorporated into Oak Ridge's moraine sediment. So those are a couple things to watch for with this version of surfaces. So I think what I will do is I will stop there. It's about 5 minutes to 3. I want to thank everyone for listening, and hopefully there are some questions. Unless Steve or anyone can think of things that I should show that I've forgotten, I'll turn it back to you, Steve.